Hi guys, here is Yanis and Vera. Today's morning, we have 11 o'clock. I hope you are well, and thanks for participation. The idea of this event came from sport because of the questions about why there's problems to connect a camera, why there is problems to connect a recording server, some other servers, and also many other questions regards to networks. And as we know, we have developed this software which works quite light and fast, but it always depends on the network. And sometimes there's latency and other issues, and maybe you will have an insight how our software is working, what is necessary for it, and many other questions. So that we have our beautiful engineer Vera. She will show her presentation and explain about the networking with Evo. So Vera, here you go.
Hi guys, it's so nice to see you here today or this morning or maybe this evening for someone. For those who don't know me, I'm Vera. I'm with Luxriot and I'm an application engineer, but I also do trainings and I also do the documentation. And as my colleague Jan has mentioned, this particular webinar was requested by our support engineers because they've collected some questions which are quite popular, and for us to be more effective, we decided to give this information to you as a webinar instead of continuous email exchange with support engineers. So in the beginning of this hour, our format today is that I will present. So I have a presentation here, full screen, so I don't see your questions, but please do type your questions in the chat. And at the end of the presentation, the last, I think, 10 minutes, about 10 minutes, I will spend answering your questions. But please don't be like very specific. Don't ask questions about your particular systems, because you must understand this requires quite a lot of time to investigate a particular case. So your particular problems or potential issues with systems that require much time to be answered, those please address those to me or to support at luxriot.com, and we will be happy to assist you with you and investigate your system. So what is this course? Micro course, nano course, probably. So this is not a networking course, because a proper networking course. So I've studied. When I studied IT in the university, it was probably a full year of the basic networking principles. So of the like theory, 7-layer model, and so on. So I won't be squeezing in all the years or even 2 years theoretical university course into this hour. So I assume that you are familiar with those basic networking principles, that you know the difference between the IP address and the MAC address. And also, I assume that you're aware of what Evo software is, what is Evo Global, what are server settings, how console looks like, etc., etc. And instead, this nano course is is a collection of theoretical information about what protocols, what ports are used in Evo, and how you should configure your Evo Global system according to the situation. And one more, probably the first top important thing I would like to point out today is that I don't know what your position in the company is. I assume I am talking to people who configure the Evo software. So like Evo administrators, right? You might be simultaneously the system administrator, or you might be the system engineer, you might be the network administrator. In any case, the first very important thing I need you to understand today, if you are not a network administrator and you're purely configuring Evo of the customer system, please understand the limits of your of your work. And behind those limits, there is the work of the system administrator of for the Windows configuration, and behind those limits on the other side, there's the network administrator, this very cool guy, probably with a beard, maybe a girl, doesn't matter, who must do all the work related to the network administration, the hardware, connecting the cables, plugging the switches, the routers, port forwarding. So all those words, you should know what they mean. You should be able to explain to the system administrator, to the network administrator, what you want them to do, what you want them to configure on the system for Evo to work. So let's dive in. Like again, this is a theoretical course, and I will list all the things, all the protocols and the ports you need to know in order to work with Evo. So I'll briefly cover all those things. So what do you need to know to make Evo work? It's best if you know what's a TCP IP stack. So what's the difference between TCP and UDP? What are those layers? Where do the IP addresses work, on what equipment, etc., etc. So, and the difference between private and public IP addresses. If you don't know that, please, there are like plenty of information on the internet, starting with Wikipedia. So start with that. So I would say that if you're working with the Evo standalone, with Evo S, you may not know anything about networks at all. So you only need to memorize 2 ports we use, and it's just digits, right? If you're working with Evo Global, you must have at least some understanding of how networks work, and what are those MAC addresses and IP networks, and what's a subnet and what's a subnet mask, and what's the difference between different masks, and what's the difference between /22 and /24, etc., etc. So the next very important thing is about ports. So we have the IP addresses, we have ports. So the port forwarding is a real thing, like a pain for our support engineers, because is a very common problem, is a common issue, because the ports are not open or not forwarded properly. Then for some more rare cases, Evo sometimes also uses multicast instead of unicast. So if you want to use that, if your customer wants to use that, you should also know what that is. Then you should know that there exist a lot of different network tools, starting from tiny ones like Ping, and to big ones like big softwares, maybe even equal to Evo in size, for network troubleshooting. And of course, different concepts, which by the way are not covered today. The concepts related to the network quality. So you also must understand the quality of your built network, the bandwidth, the latency, the packet loss, so the stuff like that. So the second thing, which protocols you should be aware of, or at least familiar with, to work with Evo. So apart from, of course, RTSP. So RTSP is generic for video streaming, but we won't be talking about RTSP today. So it all starts with IP. So IP means TCP and UDP. And then we're also talking about higher level protocols, that HTTP and HTTPS. And what other protocols, talking about network protocols, are used in Evo? That's RTSP. That's for video streaming. That's all. Then we also have video streaming over HTTP or HTTPS. Then there's also RTMP for streaming from us to YouTube. And there's also auxiliary protocols. So there's SSL for security, for emails. There's SMTP, and there's also SNMP for SNMP traps, but that's also a very, very tiny part of, and we won't be talking about this today. And of course, if you're dealing with hardware, make sure you know what's the difference between a router and a switch, and how they work, and how you need to configure this one, that one, network cables, network cards, and of course cameras and other edge devices, and the whole Internet of Things. So any device which belongs to a CCTV network. So nowadays, every one of us, even if you don't want to do that, you should be able to configure that device, to connect that device. But luckily, there is not much in this. So all these devices have different interfaces, but essentially they are they are those basic things, like all of them have IP addresses, and they have ports, and they operate using the same protocols. So they, as soon as you have decent knowledge of the things you see here, you will have no problem in configuring and understanding why those devices work and why they don't work, which is even more important. So from all those things I've just mentioned, so what's used actually in Evo software? We use IP version 4 addressing, and so we use primarily we use TCP, sometimes also UDP, and this goes for, so encrypted TCP goes for server client connections, but then there is also some client like web client and mobile client and API connections that use HTTP or plain HTTP or HTTPS. Then, like mentioned, Evo uses RTSP to receive video streams, and a couple of other protocols for smaller things. So, like we always like to say, Evo is a fairly simple software in terms of configuration logic. So we don't use a long list of ports or port ranges or something. So all you need to memorize is two things. So two ports we use is 60554 for TCP connections, that's mostly server client connections, and 8082 for HTTP, which is also a very popular option for HTTP throughout the software world. So these two are default, and you are free to change those ports to anything you like throughout your system. But when you first install your Evo S software, you have those two default ports, 60554 and 8080, and that's all you need to remember. That's just 2 digits. It's not too bad, right? So 8080 is usually also the default port for most of the cameras. So when you connect the camera, you'll be using the port 8080. Sometimes it's just 80, sometimes it's 8081. But the most common option is 8080. So for any web server, for any HTTP server, this is usually the port which is used for HTTP. If we're speaking about secure HTTP, we have a default port of 8083. So as soon as you put a check mark in Evo and enable HTTPS, you will see that you have an additional port of 8083, so they don't use the same port, and if you enable HTTPS, it means that you have both options. And also, probably one more thing to remember, so for SSL, when we're sending the email securely, we're using the 443 port, but that's also that's a default thing in the world, so you don't have to memorize it, you can Google it anytime. About transmission types, I've mentioned multicast. So what's the opposite? Or the opposite, the normal opposite of multicast is the unicast. So we mostly use unicast traffic. That means that the traffic goes from one host to another host directly and back, and it's not talking to anyone else in the network. So There are two exceptions. There are two special cases when we use broadcasting. We use broadcasting. That means when one um, uh, host is broadcasting like a radio to many hosts in the network, and we use that for server and camera auto discovery because it would be hugely inefficient to ask any individual host in the network, hey, who are you? Hey, who are you? Are you the camera? And instead, we use broadcasting. We ask everyone in the network who they are and then accept the answers. And so these, why is this important? When you run the camera auto discovery, if you run it on the remote network, so in the Evo Global, you run the camera auto discovery from a specific server, and that server might be in an isolated environment. So imagine you have two servers in different local networks which are isolated, and it is important from which server to start the camera auto discovery because the cameras in one network might not be visible to the server in another network. So as a result, you need to remember that when you start the device auto discovery in Evo, you need to keep in mind from which server you're launching this procedure. And finally, multicast is quite a rare option, and we don't actually have any special settings for it because it's sort of low level. So the only thing you need to remember about multicasting, like two things you need to remember. One, it can be enabled for camera server communication and also for Evo server client communication. And that means that instead of talking host to host, there and back, multicasting means that one server is talking to many clients simultaneously, and it doesn't actually care to how many clients it's talking. So it's the same amount of traffic if the server is multicasting to. It's just multicasting. It's traffic to 1, 2, 3, maybe 10 clients on the network, and they subscribe to that traffic and they receive that traffic. So this, the more clients, the more efficient this is. And we are also capable of accepting multicast, to subscribing to multicast traffic from cameras. And so the second thing you need to remember here, so we don't have any settings for this. All the equipment which is between the source and the receiver must support multicast. So if you want to enable multicasting on Evo server and on the Evo client, there is a check mark on the server, there's a check mark in the settings on the client. And if it doesn't work, that means that the intermediate equipment, that's most probably some switch, doesn't have support for multicast. So, right, we finish here. So moving further, I mentioned we have two options for HTTP plain one and the secure one. So we use HTTP for, you're probably, if you're around like for a longer time, you probably know what Luxriot VMS is a previous generation software by us, and it had such a thing called broadcast server inside. So so this broadcast server was actually a prototype of the HTTP server we have today. If you haven't used Luxriot VMS, just forget about this now. And right now, a part of Evo that produces HTTP traffic is streaming server. It's called streaming server, and it's basically enabled in Evo by entering an HTTP port. So if your Evo server has an HTTP port different from 0, that means the streaming server inside Evo is available. And this is something you need to keep in mind when calculating the doing the hardware calculations for your server on Luxriot hardware calculator on our website. So what do we know up to this point? I've mentioned we use port 8080 for HTTPS, and you can change it to whatever you like, because quite often the port 8080 is already used by some other service. And then also, when you're using Evo Global and when you're accessing that Evo Global system from outside world, from the internet, when you have the internet address, it's the same internet address for every server in the network. So you need to assign a different HTTP port to every server in the network. But you probably know this already, because you've probably seen my main Evo training for Evo Global, and you've read the manual, which is available in your Evo console. Specifically talking about HTTP and HTTPS, so what's it used for? So the streaming server provides HTTP traffic, it's video in containers, which is quite convenient for web applications. So that's for mobile phones, and that's for web browsers and for API clients, so which might be some other integrations, which might be your website, which fetches the video from Evo servers, etc., etc. Then it's also used for server camera connection. So even though we receive the videos from the camera over RTSP, all the service information, all the message exchange between the server and the camera, it goes through HTTP or secure HTTP. So that's basically HTTP requests. All the ONVIF, that's basically HTTP requests and responses. And so what's important to remember here? So when you configure a camera in Evo, the procedure is like you set up camera, you plug it in, right? Then you open Evo console and you enter all the settings for that camera. What do you enter? You enter the IP address, the port, and the user credentials. So what's different when it's HTTPS? You need to enter, you need to put an additional option in Evo console, and also enable the HTTPS option on the camera side, because for many devices nowadays, it is not enabled by default. So if your situation is that you've added the camera in Evo with the HTTPS option, and you can access the camera in the web browser, but it doesn't work in the software, then you need to check in the camera web browser if this option is actually enabled on the device. So this is true for like so many settings. This is also true for like motion detection on the camera side. So this is something you need to pre-configure on the camera side. So like some cameras also don't have the ONVIF option enabled previously, so you need to enable that option explicitly on the camera side, either using the camera web or using the camera tool. And the second also important thing here about ports, so this is about HTTP ports in here, but that's also true for any kind of port, and not just with Evo, but everywhere in your life where you have IP addresses and ports. So you need to make sure that the IP address is reachable, right? In order to retrieve information from the remote IP address, and you also need to know from which port you're retrieving that data, onto which port you're sending the commands, and if that port is available. And there are two things, well, like very put it simply, two things you need to do about that. You need to make sure that the ports are open on the target equipment, and you need to make sure that the ports are mapped in the right way if there is some kind of intermediate equipment that does the port forwarding. So I'll give you a second to digest that. So from the theoretical part, let's move to Evo architecture. I've put this very, very simply. So this doesn't include any specific modules or something. I've done this on purpose. So I've emphasized you need to remember just 2 ports about Evo. So for Evo standalone, where you only have a single server solution, I've put it very simply here. So if you have a server and a client, and so the Evo monitor is the Windows client, so it operates over TCP. So that means it's going to be using the port 60554, and you also probably saw that if you opened the Evo monitor. At least once. So that means you probably saw that the default port in Evo monitor for the connection is 60554. And you may have any number of those clients, but this port is set on the server. And that means that if you change it on the server, that means all of those clients will have to use the same port. Then for everyone except the monitor, for every other client, for your mobile phones, for Android clients, for Apple phones, for Mac computers, for web browsers that connect to that Evo server, the Evo server has a setting of HTTP port, and it's 8080 by default. And we were talking about HTTPS, so there's an additional settings for HTTPS. Which will be using the port 8083 by default, or the port you have assigned to this server. So these settings are the server properties. Once you change those on the server side, these are also changed. This must be also changed on all the remote clients. The difference between Evo standalone and Evo Global, hopefully you know, is that Global is the multi-server system. I only put one recording server here on a diagram, but hopefully you know that Evo Global has different roles of the servers. So they might be mirroring servers, there might be replication servers, there might be failover servers, but they all essentially use the same installation of the Evo recording server. So here, what you need to understand today is that so these servers talk to each other over TCP. So that means they're using the 60554 port or whatever port you have assigned, and the rest is essentially the same as in the Evo standalone system. So the clients are using the 60554 port, and the mobile clients and the other HTTP clients are using the port 8080. So that was quick, actually. So let's move on to more theory. So now imagine you're configuring the network for Evo system. So what do you need to know? What is this knowledge that is sacred and that will allow you to successfully configure it? Actually, there is no secret. There is like general common sense and some basic networking principle. So this number one, which is like totally approved by our support and by our own network administrator. So this morning he said to me that this is the best. So guys, please, when you do the system configuration, do draw the network topology, do draw all the architecture. Take a pen, take a pencil. Maybe you prefer to do it in the software, so then take the Draw.io or some other kind of software and draw a scheme, create a diagram that will give you the understanding of what is there on the network. Mark all the ports, mark all the IP addresses in there, write out all the ports, all the subnets. This will help you greatly throughout the deployment and throughout the maintenance and troubleshooting stages. So next, you need to talk to the network administrator, make sure he configures everything right, he opens all the ports for you, he forwards the ports for you. So then if something doesn't work, then you need to check if all the servers are reachable from this point, so that this server is reachable from this point and from this point. So use your diagram to troubleshoot and to check these scenarios that you will need. And for this, you use the network administrator, you use his head, you use your head, and you use different tools to verify that connectivity. You don't just you don't check if there's signal on the cable, right? You use higher level tools to verify that there is actually the connection between the two hosts. So why can't I reach the remote server? So you don't use like the crystal ball to guess why it doesn't work. So the modern software community has developed lots of different tools, like starting from ping and tracing route and checking ports or checking network bandwidth and load and port availability and host availability. So my suggestion is that like you probably do have some tool set at home, like a default your favorite screwdrivers and stuff for doing some kind of micro repair works at home. So it's just the same with networking. Use your tool set and get used to it, get familiar with it, and you will be very effective with it with troubleshooting and maintaining your networks. And speaking about Evo, like the most important tip that I would like to pass on to you today, when you configure Evo, so everything you do in console, every setting you do there, everything you write is actually about teaching Global about every device. You don't configure those devices in console. Well, sometimes you do, but when we're talking about networks, all those settings you enter, they teach Global about those other devices. So that's what it is about configuring from scratch. So what if it doesn't work? What if it doesn't work from the start? Or what if it doesn't work somewhat later? So what do? So first, you use your drawing. So either a diagram you created, or maybe it's a paper drawing. So personally, I prefer paper because that's the way like my mind operates. But it's totally up to you. The important thing is that you have it and that you can compare the differences. So when something goes wrong, you can check. So this port should be different. That port was different than the initial configuration. Maybe this is the problem. Then ask the people who configured that network. Maybe they did some changes. Ask them to check the hardware. Ask them to verify the network load, etc., etc. So if you are not the person who configures all the ports and all the firewalls, by the way, which is very important, so you need to make those people check those firewalls for you, because this is like a very, very popular issue if your ports don't work. So the rest of the slide here is actually common sense. So how do you troubleshoot a network? So if it doesn't work, you need to ask yourself questions. What exactly doesn't work? Can I send packets from this host to this host? Can I send packets from server to server, and from server to client, and from client to this server? Does it work? What might be the problem? If you've built a new configuration and it doesn't work at all, sometimes it's the best to throw it all away and start from scratch, because you have your drawing, right? And if it is an existing system and you're troubleshooting what has gone wrong, you might be wanting to ask the question, what has changed? It worked today in the morning, but it doesn't work now. So what has changed? And apart from the network problems, so nowadays a very, very common issue is Windows updates. So it's like, hello IT, try turning it off and on again, and then do all the basic troubleshooting according to common sense. And don't be afraid to ask for advice from your colleagues, from network administrators, from system administrators. They're all awesome guys, right? And in order to help you with all that, like I said, there are a bunch of tools. There are just a few of them. I haven't gone into much detail in here, but these are just like very, very basics you must use like every time. So um, if you're creating a new installation, if you're creating a new network, so the subnet calculator is your best friend. So, and at all times in your life, the command line tool and the PowerShell are your also best friends. So, because they have like those tiny little useful things like pinging hosts, tracing the routes, using Telnet or TNC for checking the port availability. And then finally, of course, there's Wireshark, when you can actually see what kind of traffic, because maybe you're sending the right requests, you're not getting the responses. Then that's also that's already a higher level investigation. But in any point in life, not just with you, not just with networking, use the common sense, use your mind to ask all those questions. What is wrong? Why is that? What is this? What has changed? Etc. etc. And you'll succeed. So let's move. So Yanis tells me we don't have a lot of time, so I'm gonna be less verbose. So specifically in Evo, so like I said, the most important thing, when you configure networks and like any ports and something in console, you're teaching Evo Global. I'm talking specifically about Evo Global because with Evo standalone, it's very simple. It's just 2 ports and no problems. If those 2 ports are open on the firewalls, on the equipment, then you have no problem whatsoever. So with Evo Global, with a multi-server environment is tricky. So I'll be talking about global from now on. So, and this is a very important concept to grasp because it basically means that in Evo console we can enter some network configuration which might be logically wrong, but it's perfectly legitimate, and you will see why on the next slides. But there is also an important notice here, which I've already mentioned. From Evo console, you don't change the ports or IP addresses of any remote device that you have configured. When you enter the camera configuration in Evo, you add the camera IP address and the camera port. If you want to change the camera IP address, you change it on the camera web, you don't change it in console, right? It's the same for recording servers. When you have the recording server added in console and you want to change the IP address, you don't change the IP address in the Evo Global configuration, right? So there is a special tool called Server Setup Wizard. You run it on the recording server side and you change the port in there. And that's the correct procedure to do this. And it's also true for any ports you have configured in Evo console for devices, for edge devices or for servers. So next important question we need to cover today, and it will take us the next 10 minutes, I think. So it's, when do I need to use networks in Evo Global? So in Evo console, there is a special section called networks. And in most cases, when your architecture is not complex, and you don't need this, and that's also the reason why you don't have it for Evo standalone. So the key concept here is the following. I've already mentioned, you teach global about the other servers whereabouts. So basically, the question you need to ask yourself to decide whether you need to add networks in Evo console or not is that, is my global network similar to a large virtual network where every host is reachable from any host, regardless of the IP configuration of those hosts? If the answer is yes, then it's perfectly legitimate to enter like to make everyone a member of the Evo Global local network, and that's gonna work. So if the answer is no, if the answer is that no, there are some remote local networks with public IP addresses, and I need to get behind those public IP addresses in order to get to some remote servers, then the answer is yes, you need to add networks into Evo Global. So we are gonna see a couple of examples here. So I've sketched out the popular examples, and we're going to move to them in a couple of slides. But first, a couple of things about general stuff, because this one was particularly requested by our support engineers. So they asked me to give you this precious information. So this is their advice. So the port availability is on the top 3 issues with networking with Evo. So the server is not available, or the camera is not available from somewhere. So the important step-by-step procedure is here that you set up the ports on the server, on the camera, on the client, and then you open all those ports, and you open on the intermediate equipment where it's required, and you map them, or you ask your network administrator to forward the port for you and open them on the firewalls. And then, like I said, you use tools to check if those ports are available. And remember, please, that ping is no sign that the actual socket connectivity is working. So because you don't, unless you're using a specific ping to a specific port, the regular ping, like the ping command on the command line, it doesn't check the port availability for you. And it doesn't, if you can ping a remote server, it doesn't mean that the software will be able to connect. So that's why you need to use special tools to verify port availability. One of those tools, it's built into Windows PowerShell, is TNC. So that's the image on the right. I'm using the TNC IP port and then the port to verify a specific port on a specific host. So you can do that. And so again, going back to Evo, like I said, if your network administrator provided you with a very convenient environment to work in, where you have a lot of different subnets with VPNs in different cities, maybe in different buildings, but that all of this whole virtual network works essentially as a big local network where you can access any server from here to there, no matter where it's located, using just its IP address, then you don't need to create any additional stuff in Evo Console. You don't need to add any additional networks in Evo Console. Just make everyone part of the Evo Global network, and that's it. That's going to work perfectly. If that's not the case, that's a more complicated case, and then you will need to create additional networks in Evo. Each network in Evo has the title, the subnet, and the entry point. And we're going to be talking about this later. And the third scenario, if you only have a remote servers, which are individual, you don't have a whole network of servers somewhere, I don't know, in Hamburg. You just have one server in Hamburg using the public IP address, and you have one server in Prague having another IP address. You just add them as internet-only hosts. There's the example in the presentation. So that's the option you need to use if you don't have a bunch of remote networks, but you have individual remote hosts instead. And I'm talking about recording servers here. So with all those network architecture, so you might not be familiar with the whole network, but the question you need to ask when configuring, can I connect from this server to that server? And if I can, how can I do that? And if you can't do that and you need to do that, that's the question you need to ask to your network administrator. And a couple of examples. Yeah, we're running out of time, but so the simplest example, which I just mentioned, or probably even a simpler one, when you just have one network, one router, one subnet, and everyone in the same subnet. Here it's 0.35. It's the simplest one, right? I've only sketched one recording server here, but you must assume you might have more recording servers, but they are all on the same network. Then in Evo Console, you don't need to create anything additionally. You just need to put everyone in the same network, which exists by default and is called the global server network. And so each recording server you just add their IP address, and you add them. You set their setting, their network setting as global server network, so that they belong to the same network as the global. And thus, global will assume everyone's his buddy, everyone's his neighbor. There is no public IP address used here. That means global thinks, okay, no one's going to address us from our side, so I don't really care about addressing. So any server that talks to me, I'll assume he's my neighbor, I'll assume he's in my LAN, and I will send the traffic over the local interfaces. Hopefully that's pretty obvious. I'll leave you here for a second. And move on to the second example. It's a bit more complicated. It's essentially the same. This is this example I was talking about originally. So no matter how complicated the actual architecture is, if the network administrator did a great job and did this transparency for you, so no matter how many VPNs are there or how many routers are there on the route, if you can access directly one host from another host, even if they have different IP addresses, that means in Evo Global, you can have a virtual LAN, and this will be essentially the same configuration in Evo Global, provided that you don't need to access this network from outside world. So this is so mostly CCTV systems are isolated from the real world, right? So if you don't need to access it, if you don't want to make it public, if you don't want to assign any public IP address or domain name to it, this will work also perfectly for your scenario. And there is one counterintuitive thing here, and at least for me, which says that here in Evo Global network, here's when where the local mask is. You can actually set up any local mask there is. It will still work because as soon as global has no public address defined, it will still treat every server as his buddy, as his neighbor. So he will still think that they are on the same local network. But again, this will only work if the network is transparent and if there is no public entry point. So those other scenarios are more complicated and are not covered today. So let's move on. Example number 3. It is similar to the previous one, but the difference is that here there is no direct communication between the two hosts in those networks, but instead the remote network has an entry point, has a public IP address, so no VPNs, a public IP address assigned to the remote router. And this is exactly where you need to add a network in Evo Console. So what does it look like? We add a new network. So on the top image here, we add a new network. We define the network mask and we define an entry point. So it's called a public IP or an internet IP in console configuration. In this example here, you can I've used both IP address and the domain name, so you can use either this one or that one. It is essential that you define this entry point, so the router address must be this public IP. And in here, so all my remote network, which is behind the router, I add it as an additional network, and then all my recording servers, which are in that remote network, I assign them to this remote local network. And that means whenever Global needs to connect to that recording server, he'll see, okay, he's not in my network, so I need to call this number 71102 in order to communicate with those guys on the remote network. So every recording server which is on that network needs to be addressed through an entry point, and that entry point is this public IP in Evo console configuration, in the network configuration. And that was the end. That was the unexpected end of presentation. Maybe you thought I was going to give you more examples, but no, these are the most popular scenarios. And if I understand that the real world is more complicated than that, and but I would like you to understand how those concepts I gave you today, and you test those on more basic scenarios, and then move on to more complex scenarios. And of course, we are here for you for your concrete system configuration, for your network configuration. We are always there to help and to assist and to investigate your settings, to give assistance, to give advice. But of course, today, hopefully after today's lesson, you have more understanding of what to do yourself, of what things you can do, what steps you can do yourself in order to troubleshoot that before contacting our support. And you now know which information our support will ask for you. So now you know what information you need to supply them with in order for us to help you. So now sit back, relax, and so this the last but not least idea I want to give you today. So guys, be a bit playful, like my cat. Don't be too serious. Don't be too shy. Don't take the world too seriously. So we're going through harsh times, and so this whole COVID, and God knows what what is waiting for us tomorrow. So take a moment, learn, play, and have fun. And I thank you for listening
Yeah, Vera,
to today.
we have a question.
Yeah, and
Yeah.
so I see that I fit it into the time frame. So I'm gonna be able to switch to the questions now.
Yeah, and while Vera is reading it, maybe you have any questions? And another topic is maybe you could give advice what technical or trainings would you like to see in the future. So you are welcome to say or to write in email. Yeah, we are planning an events for this year, so maybe you have a great idea.
Yeah, so the question from Rafael is why an example is one network and I have configured it like another network. So are you referring to which one of my examples? Because I don't have a network with the 0.1. But anyways, in your question, 192.168.1.1 is a host IP address. And in the default network notation, when we use net masks, using 0/24, so like in here, 0.1.0/24 indicates that I am defining a network, a subnet, not a host. But like I mentioned in Evo configuration, in Evo Global configuration, this doesn't actually matter. So when you have a configuration like this, for example, so in this particular field with a local mask, as soon as you don't have any public addresses, it doesn't actually matter what you enter in this local mask. So you're in this example here, I'm using a strict theoretical subnet addressing. So 0/24 is a proper way to indicate that we're talking about a subnet, not a host. And but as long as I'm concerned, you can enter 55.1, 55.2, 55.0/24, like any. So like I mentioned, if you pay attention to the second server of the network here, it is from a very different IP address range. It's from 10.10. something. It is a different private IP address range, right? So as long as we're talking about local addressing here, as long as we don't have any public access to this network, this is totally okay.
Okay, guys, maybe someone wants to turn on the mic and ask a question, or yeah, Rafael is still typing. Maybe there's other question we have.
Yeah, success would be great to have a webinar dedicated to types of redundancies and the configuration. So you mean like failover and stuff, right?
Yes.
So it should be a mistake in this example. Yeah, I might have a mistake because I created those diagrams like late in the night, so I might have a typo somewhere. Do you mean this one? Do you mean example this one, number 2? Yeah, like I said, once again, no, there is no mistake in this example. You mean example in the menu is the description of the local mask field. Well, yeah, and I know what you mean now. You mean the field description in here, which says example 11/24. It's not a mistake because, like I said, Evo doesn't use like strict logical rules for networking because we don't actually do the network configuration in here, right? We're teaching Evo Global about his neighborhood, and we allow you to be flexible in here. So there is no mistake in writing it like this, because it will. There is no difference for Evo Global to if you put it 1.1/24 or you put it 1.0/24. There is no difference for the server. It's important for him that he understands that the network size, the subnet size, and the IP address is more of a convenience for you to see to which range it belongs, because there might be like different subnets, and so it's more important for you, for the user, so that you can differentiate between different networks. So no, formally in formal setting of subnet, that will be considered a mistake. If you put it on the router, there will be a real difference, because the router is a network device and it understands strict rules considering addressing, and strict rules considering how IP address should be set. So in here is a bit counterintuitive, and personally I don't like it because I like it when the things are logical and structured, but in here there's a bit of anarchy in here, but that also ensures that if you put something a bit wrong, will still work, so Evo will still work. Yeah, but thank you so much for being very attentive. And maybe there are other questions.
Yeah, I believe maybe not. If there's other questions, please call us or write an emails, and then so we are waiting for you. If there's
Yeah, I would
some,
love just a couple of words. Sorry, I would love to have some kind of feedback because I structured this webinar because there were like things I wanted to say to you. I wanted to make sure you know them, and I would love to have feedback on was that good? Was that enough? At this point, I understand that there's always more, but so any kind of feedback you have, I'd love to hear that. Thank you.
yeah, maybe about the practical training, hands-on or something else. But what about this theoretical part? So yeah. I hope somebody can write a comment or turn on a mic. It would be nice. Or we already.
Yeah, I actually wanted to make a poll for you, but I forgot to, and we're already out of time. So I'm gonna do that next time.
Yeah, still no answers. Maybe I could have a call with some of the participants
Okay.
and then could get a
Yeah,
feedback.
was it useful for you, Yanis? Was it good for you?
Yeah, I'm not IT guy, but even me understood that there is some logic and steps need to be taken, and there's already tools, name tools, which I could use to do a proper testing and configuring of the network, and so even for me, global could work. Yeah, I believe I would need some assistance from support, but support is here, and then it also will help you. So yeah, for
Yeah,
me it was
good.
useful. It was something new for me. Yeah.
Good. That's good. So I'm looking forward to next nano lectures. So let me know if you have like specific topics, like so Yasin said you want a redundancy lesson, so I'm gonna give you one real soon. So meet you there.
Yeah. Okay. Thanks. Thanks for participants. Thanks Vera for presentation and asking all your questions and various answers. So till the next time, have a great day.
Yeah, have a great week. Have a great life.
Goodbye.